Good day, ladies and gentlemen. Welcome to Code Switch in 2020. Today we continue with our grade 11 physical sciences. Today we are going to be looking at Newton's law of universal gravitation. So, Newton's law of universal gravitation is an application of Newton's third law. So, these are the forces originating from the interaction between two bodies. So, in other words, it doesn't mean that the bigger body exerts a bigger force on the smaller body. They exert a force that is equal in magnitude. So, what does Newton's law of universal gravitation say? It states the following. Every point mass attracts every other point mass by a force exerted along the line connecting the two. This force is proportional to the product of the masses and inversely proportional to the square of the distance between them. So, the force is given by F is equals to G multiplied by M1 multiplied by M2 divided by D squared. So, what does F stand for? Our F is our force of attraction. What does M1 and M2 stand for? M1 and M2 are our masses, and the masses must be measured in kg. And we know that our force is always in Newton. So D will be the distance and the distance must be measured in meter. What about G? G is our gravitational constant. And our gravitational constant has a value of 6,7 multiplied by 10 exponent negative 11 Newton multiplied by meter squared multiplied by kg squared. That's our gravitational constant. So, how do we apply the Newton's law of universal gravitation? We have two types of problems. The first one is the calculation based on the formula. The second one is the calculation based on proportionality. So, in terms of proportionality, what does the law describe? It describes two things. Let me get a space. We said in terms of proportionality, in terms of proportionality, the law describes two properties. Number one, it says we have F equals to G into M1 multiplied by M2 all divided by D squared. So number one, it says that the force is directly proportional to the product of the masses. The force is directly proportional to the product of the masses, meaning that if the masses increase, the force will also increase. If the masses increase, also the force will increase. So, for example, let's just say one of the masses increase. So, if the mass of M1 increase by 2, what's going to happen to the force? Then we'll say it's M1 multiplied by M2 will be 2 times 1 is 2. So also the force will increase by 2. Is that clear? So if, for example, both masses increase, then meaning will be M increased by a factor of 2 and M2 increased by a factor of 2. Then meaning we're going to say 2 times 2 is 4, meaning our force will increase by a factor of 4. So that's number one. So if only maybe M2 increased by 3, we're going to have M1 multiplied by 3, M2. So it's 1 times 3, it's 3, meaning our force will increase by a factor of 3. So because of the force is directly proportional to the product of the masses. So if the masses double, also the force will double. If the product doubles, meaning it's going to be 2 mass, 2m1 multiplied by 2m2, our force will increase by a factor of 4. So another one, it says the force is inversely proportional to the square of the distance between them. What does it mean? Number B, the force is inversely proportional to the square of the distance between them. It means if the force increase, the distance decrease. If the force increase, therefore the distance will decrease. So let's take example. If the distance between the bodies increase, F will also increase. Okay, for example, if the distance increase with a certain factor, therefore F would decrease with that factor squared. And vice versa. So meaning if the distance increase with a certain factor, F will decrease with that vector squares. Or if the distance is halved, then then F will become 2 squared bigger. That's how the proportionality work. So let's look at an example. Okay, let's look at the following example. It says, determine the force between object A and B with masses 150 gram and 230 gram, respectively, if their centers are 1,5 centimeter apart. So one thing we need to know is that the distance is between the centers of the body. Meaning, if you have object A, and this is the center of object A, and object B, and this is the center of object B, the distance are from the center and in this question they said they are 1,5 centimeter apart, and object B is 230 gram and object A is 150 gram. So the question needs the application using the formula. Number one, we need to convert. We said the masses must be in kg and the distance must be in meter. So mass of A, which is 150 gram, to convert it to kilogram, we need to divide by 1,000, meaning it's going to be divided by 1,000, which is going to be 0,15 kg. Then the mass of object B, which is 230, will be divided 230 gram divided by 1,000 will be equal to 0,23 kilograms. Then the distance must be converted to meter. Then mean you're going to say 1,5 centimeter divided by 100, which will give us 0,015 centimeter. Then once you are done with your conversion, you can use the formula. The formula stated that F equals to G multiplied by M1 multiplied by M2 or divided by D squared. Our G is given by 6,7 multiplied by 10 exponent negative 11. Close brackets, M1 is 0,15 into 0,23 minus 2, all divided by our distance, which is 0,015 all squared. Remember to always square your distance. Then when we punch on our calculator, we get 10,273 multiplied by 10 exponent negative 80 Newton. And the force is always the force of attraction. Then write attraction. Let's just do a quick recap on our calculations. The question stated the following: determine the force between object A and B with masses of 150 gram and 230 gram, respectively, if their centers are 1,5 centimeters apart. Object A is 150 gram and object B is 230 gram, and the forces between the centers of the two objects, which is D, which is 1,5 centimeter. Then the first thing, you convert your masses into kilograms, your distance into meter, not centimeter, into meter. Then you use your formula, correct substitution, and correct answer. And the force must always have a direction, which is the force of attraction. Thank you for watching. For more videos, please go to Code Switch in 2020.